Hi everyone, my name is Vinay. Uh, I'm a data scientist with Adobe, and I'm working on different data technologies from last 7 years. And today we'll be talking about data science with real life examples. Well, guys, today's agenda is that we'll be talking about that what exactly is the data science is. That since it's a pretty old subject and everyone is talking about it, but we'll go through with it some nuances and some basics about data science and some evaluation or probably a difference between data analytics, that's a simple data analytics versus data science projects. Uh, the third thing we'll be discussing today is the framework for the data science projects, because that's an important thing that you'll be doing on your data science project, data analytics projects, and then this is the area where you differentiate that which particular project belong to where, and what exactly is the differences is our key area we're going to look at. After that, we're going to discuss each and every step in this process in the framework, that how we do it and when we do it, and what is the significance of that particular step. There may be a chance that you may skip a particular process or step because it's not required as per the business, but we'll be discussing in detail and we'll take that forward. After that, we'll be discussing certain techniques and algorithms in the current state right now which we are using. We'll not be able to cover everything, but probably we'll go through with it, like we'll just go through the basics one, and probably we'll try to cover some of the business cases and some case studies where we can see that how that works. We'll be using today in our session, we'll be using R for our demonstration case study purpose. And this R code will be available for you guys at later point in time if you want to access and want to run it on your own systems as well. Sorry,
Live no, na? Live.
uh, I think we have some disturbance. If you, I would appreciate if you guys can put your speakers on mute. All right. So, what exactly is the data science is? And since this is I would say this is a kind of term which is being used everywhere these days. And some of the folks, those who have been working on data analytics project for a couple of years now, there's suddenly a boom in terms of data science, and everyone would like to explore that area. But before we get into it, I would like to cover, probably like would like to give some time to understand that how it is different from the analytics and where we use it, and uh, what are the key areas which actually makes it different from the simple analytics. So one part which we all are aware about it are data warehouses. I'm sure that most of you have worked in a relational database systems where you have data coming from Oracle or SQL Server, and then you're using or writing queries on top of it, and then probably have created certain dashboards on it. And these dashboards being used by higher management or some of the analysts, those who interpret this, and then communicate to business in terms of what is happening in business right now, what is the need, what's the certain action which you need to take, right? How you achieve your targets, what are the pain areas, who is performing well, which particular market is going down, kind of questions which we actually try to answer with all these dashboards. These are very straight questions which we ask, and for analysts it will be over a period of time. If you're domain expert, you know it very well that how to interpret all these signs in your dashboard, and when you work over a period of time, then you also know it that what sort of actions you can take to rectify all these things in the coming way or in the coming months. On the other hand, I would like to talk about the products which we are currently building that somewhere make our business smart. Some of the decisions which we take right now probably can be automated. There are chances that some of the analysis which you are doing can directly be incorporated in a system which can take a decision and can take the redundancy out. So one of the example will be that if let's say that if you have a dashboard and you know that the certain metrics is whenever it goes down, probably you need not to open that dashboard probably on every Monday or Tuesday and then report it to your manager and then he takes a decision on top of it. Rather than you create a system where you have already set a flag saying that whenever it is lower than let's say 10% or 15%, automatic raise a flag and take action on top of it. So these kind of products we are talking about, and this is the area where we try to explore or probably put some sort of intelligence into the system, and that is where the data science all come into the picture. I know there are uh, different discussions where you say that data science is a part of analytics, and per se that analytics is actually such a broad subject, or probably a very wide area that in the realm of analytics, you probably have everyone who's working on relational databases, NoSQL databases, all the data engineers, those who are providing the data to us, all the analysts, those who are studying all these dashboards, the people, those who are creating predictive models on top of it. And now that there's one more layer, that people, those who are creating smart products, those who can take decision on their own. End of the day, the target is to somehow achieve our business success metric. It can be dollar value, it can be retention, it can be customer satisfaction, it can be in any of the business areas. So end of the day, that what we are trying to achieve is a goal, and how do we do it is it's all about in the part of data analytics, that how we report things and then can take actions on it. It can be in a normal traditional way, and now there is a smart way of doing it as well. So uh, before I move ahead, uh, few more things I want to highlight about data sciences. This is not different in most of the scenarios, not different from your normal business analytics or uh, data analytics job. It's most of the time covers all the basic areas which you do in your day-to-day job, but there are some added advantages or probably some certain other actions which you can do on top of it to probably automate the process, or probably make up something which can take its own decision. So in normal business analytics scenario, you'll be covering all the normal business administration work, kind of like marketing or probably managing the campaigns or some sort of, if you're reporting the finance numbers, uh, probably equity, or it can be anything in terms of in business context. Uh, the one part of an analyst job is to explore the data, and I would say that this is the biggest part of any analytic job, that you actually probably explore and try to come up with certain facts which is not visible directly in the system or in the data. You try to gain some sort of knowledge over a period of time on this, and then these insights which you actually flow probably into the management, ask them to take certain decisions on it. uh, the one old layer which has already been working, or probably that I know that there are a lot of statistics folks, those who are working on predictive models on all of this data. And now there's a third layer, as I spoke before that, which is your data products, like smart products which you actually try to build on top of it, this data. I'll be covering these, some of the examples of these uh, products, and some of the real-time scenarios that where companies are using it right now to make the experience better. And this is the real-time analysis which you are doing. And there's one more important part, that the time which you take in the process of understanding it, analyzing it, and then communicating it to business. Uh, on the other hand, you have products which really have to take a decision on the uh, in the real time world. So there is a huge lag in between the decision process, and which will be I'll be covering in my next slide after this. So before we get into the data science projects framework, I would like to talk about the data analytics lifecycle, normal project lifecycle, which is quite conventional. You probably you discover the data, what exactly you need for your project. Let's say that you are trying to analyze your customer experience. So you try to look at the data for a specific region or geo. Then you prepare the data that in terms of what is required to do that analysis. For an example, let's say that you are doing any sort of customer analytics or behavior analysis, and then in terms of data prep, you'll be looking at that what they are doing on your website or probably in the offline world as well. And then you take all these variables and create a model on top of it. Now, in the process of taking this data and making a model on top of it, it requires a lot of business knowledge or domain knowledge to understand that what can be useful for you. Again, one of the example can be that you are looking at their online behavior, but some of the variables like how much they earn per month or probably their credit card expenses can be useful to know that which bracket they belong to. So some sort of categorization. Where you want to target these customers, what is your end goal it's what require needs to be discussed at this stage. After this, you take this data and build a model on top of it. Once you have a model in place, you communicate the results to business will look at it, look at the business value they're getting out of it, and try to optionalize this. So they put it in the production. Now you have a report ready. The report is giving a number which is useful, which actually is useful to take certain decision end of the day, and somebody is using it in business. So this is a very typical data analytics life cycle. This can be applied anywhere in terms of relational database world, where you have where in the discovery you can see where what all data you want to capture. It can be like CRM data, it can be finance data, which maybe you're flowing in your SQL or Oracle server, then preparing this data so you can use it, because most of the time the data which you are getting may not be in the right format. And after that, uh, building a model on top of it. These models can be anything in the range of just predicting or probably talking about the linear behavior or just reporting the numbers also. So you may or may not have a proper model in place, but end of the day that this is the number in the shape of what business is looking for in data analytics world. Now with this, I will move to my next slide where I was talking about that what exactly is the difference between the analytics projects and data science projects, and why this is so important right now that every company would like to invest or get into this space and would like to hire somebody who can do this job for them. So one of the example here is that in your normal data analytics project, when you are analyzing the data, then some sort of inference which you get out of it, you take a decision, you probably communicate it to business, and end of the day, they do certain changes based on those analysis, and then that improves your customer experience. This is a one kind of flow which we normally see in our business. Now, the biggest challenge here is that by the time you you analyze it, analyst take some sort of inference out of it and communicate to business, you have already lost certain amount of time in which customer could take an important decision. So one example can be that someone wants to buy a phone. When they want to buy a phone, they are just looking at probably different cell phones right now available in market. uh, they go to any website, they look at the new models available. Someone takes this data, dumps it somewhere, analyze their behavior, and reports it to business. In the process, they realize that the category which belong in the range of 5,000 to 10,000 performs pretty well. So certain models, those who probably cost more than 10K, can be put into the 5 to 10K budget or probably range. And that may inflate their sale. Now, by the time you give this or probably communicate to your business, and business takes a decision and change something on website, you have lost a lot of time in between. By that time, the customer might have moved from the online world to offline world, because he couldn't take a decision at the right time. He may have gone to a store to buy a product, and you have actually lost an opportunity in between. Now think about the same scenario in which the same customer is coming on your website. The they are generating some sort of data for you so you can analyze their pattern. Now on this data, if you can write an algorithm that can predict the behavior or that can say something about the customer, and based on that, if a layout or probably the experience for that customer can be changed, then the decision process itself become very easy for customer. So the one example can be that you have a certain mobile which is available, what customer is looking for. Based on their behavior, you can say that this is the product they want. And if you can populate that product at the right time in front of customer, there are high chances that they will buy. Oh, there are other scenarios as well, which I'll be talking in coming slides. But this is the one of the reason that all the ads which you see on your Facebook, probably on your Google search on the right, and in your Gmail also, has a significant value because they know it that at that point in time, what is the need of the customer or what customer is looking for. That is the reason if you search for, let's say, a let's say a washing machine, probably you have all the websites which will be giving you the display ads which is related to electronics or washing machine, because they know it that this is the right time to pitch in and actually grab the opportunity. And this is where that you start seeing Amazon and Flipkart showing you all those display ads to you. Now, as I mentioned before, the cost involved in the process and the time it takes. So if you reduce the time, makes the experience better for customer, there are high chances that your revenue go up because the customer experience is directly correlated to the revenue which you're generating on your website or probably in any business in some other way as well. Now let's talk about the data science world. That so far we have spoke about that how the analytics project work, and then what can be the advantage to implement a probably a data science framework which can learn on its own. Now how do we do it? Now the data science world is not as straightforward as the analytics world is, because the decisions are very dynamic. So one example can be that a decision probably algo is taking for one customer may not be relevant for the other. A customer, let's say, that trying to figure it out something, let's say on Amazon Prime, which is a very popular streaming service right now in India. If you go to their website and that if the recommendation which they populate for you, it's relevant for you but may not be relevant in your family for your father and mother, because when they look at that content, when they look at the home page, all the content which is probably in some other language or probably you have your own preferences may not be relevant for them. So in that case, how you can personalize that and how you can customize what the level it can go to. That's the reason it become little complex. Then and that's the reason it's a back and forth between your database, your uh, algorithm, or probably the logic and the end result which you are doing. Uh, so in a normal data science world, what all starts with the feature engineering. That all the variables which you are feeding into your system matters a lot, because your model is as good as the features you are injecting into it. The more you features you put, the more data it has. But at the same time, all the data may not be relevant. So most of the time, if you look at in today's world, when we talk about big data, big data may be relevant, probably that you have thousands of variables available for a customer, but most of the time you don't have values for them, or you don't probably get a right value. So you get something which is complete garbage and which really doesn't make sense. So end of the day, you don't need 1,000 features, you just need 10 features that really make sense. That is the part where the feature engineering comes into picture. And this is a very important job for any data science project, because as soon as you figure it out that what all features you want to use, the further process heavily rely on the feature engineering itself. As I said before, that the model and the accuracy also depends on the quality of the features and the data which you are feeding into the model. Now the model fitting. Uh, this is one area that people try different algorithms, and there, as you know, that in today's world, there's no dearth of algorithms. If you probably open R, and then if you look at the number of packages available in R, you will figure it out that it's probably not possible to explore each and every library and package. So that which particular algorithm to use and why to use it? What are the advantages of using it? And what if there is an improvement with some other algorithms? So how do we decide on that is the second important part. And end of the day, whatever model you have created, if I evaluate this with my real-time scenario, probably the new data set, because I have learned on my previous or probably the past transactions, and that I really want to apply this for the future data sets, and the data is also changing over a period of time. People may like one thing in October, may not like the same thing in January. So that you have your all the changes happening, the dynamics of the data is also changing. So the model fitting, the model evaluation and model fitting, it plays a major role. That how well it fits. Maybe it works pretty well with the current data set, but it should work equally well with the future data sets as well. So how that can be implemented. And then once you have figured this out, uh, for any data science project, or for, let's say, for any analytics project, I always emphasize on the fact that what is the business value you're generating out of it. End of the day, it should have a clear goal which you're trying to do. uh, as I said before, it can be revenue, it can be experience, it can be probably the time the customers are spending on your website. So it should have a clear goal which you can achieve, and then accordingly you design the process. So if you are not clear in terms of what you want to achieve, it'll be the entire modeling process will be weak. So there is no point of spending time on data and modeling without even knowing completely that what you want to achieve end of the day. If that is clear, that probably smoothes the process further. uh, in real-time world, there's also a challenge that you need to acquire data. So you have one kind of data. uh, in your traditional world, you have all the revenue generated by a customer, how much they are spending on your products, which product they are using. But now you want to probably customize it to a level where it's very personal. So as I said before, that Amazon probably would like to customize the experience for each and every user or the profile they have on a single machine. So how they do it is that how much data they can get out of the system. Can There are possibilities that you need to look for variables which is not available in the current domain, or as I said before, that the, let's say, your credit card history, uh, if you are, which is completely irrelevant in terms of streaming services, because you just want to see a video and you're paying for it end of the day. So how your credit card information can be relevant. But these kind of correlation, the creativity in terms of finding the relationship between the data sets, is what the job is of a data science. It's the creativity and the curiosity that drives you to explore more and more in these areas. And end of the day, once you have everything available, you put everything into the development system. Now, this is not a one-time thing. You will not be doing it, or the model will not be training it one time. You probably may have to train it within the span of like 6 months or 1 year once again, because whatever you have learned with the current data sets, as I said before, may not be working for future data sets. So again, it's an iterative process which will be going in a circle, and then you have to keep coming back and looking for the other features. So this is where that the entire game changes. Now, how much time it takes for the circle to complete, probably, because like one of the example can be that the Google refreshes or probably learns the data on their algorithms, probably some of the models which they train it on everyday basis, some of the indexes which they generate every night, because they really don't want to lose an opportunity. They really want to learn as much as possible and as soon as possible about customers. So they never probably some of the crucial things which they'll be doing is that on some of the areas that they probably update the model very frequently. So again, it's completely a business decision that what is the time frame you would like to set, but it's a iterative process, as I mentioned, and you'll be keep on doing this to explore more. So it's a never ending process, in short. If end of the day you are your business goal is to generate revenue, you probably, let's say that right now your accuracy to predict the revenue generated by a customer is 80%. Tomorrow you will be looking for something between 80 to 85. Once you have that, then you'll be looking in the bucket of 85 to 90. So you really want to be accurate as much as possible going forward with your data set, and you want to learn more. One of the example which I want to share with you guys here is it's a Google example, and if you guys remember that the Google voice search, which was available a few years back as well, and the precision on that algorithm was around 98%. So they can recognize that a human voice with around 98% accuracy. Now the accuracy, which they have trained over a period of time pretty well, the accuracy is around 99.5 or even uh, more than that at times, and which you can compare with human accuracy to rectify or probably identify somebody's voice, which is right now almost as much as a human can detect. So this is the kind of process which you, as I mentioned before, that you'll be keep on learning and keep on improving. All right. As I mentioned before, when you're talking about machine learning AI, which is now a core part of data science, there's one company really which has innovated a lot in this area, and that is definitely Google. There are other companies as well, but the Google is a pretty known face, I would say, in the area, and the applications which I'm sure that most of you are using in your day-to-day life. So the one of the example is the live traffic which you get. So when you leave from your office, you check the traffic, and it says that it may take probably 30 minutes for you to reach home. As soon as you come to the parking, probably take your car out, hit the road, you see and you check the traffic again, and this shows the times. It says that it will take you 35 minutes. So what exactly happened in 5 minutes that the time has changed completely? That there is again now the variation of 5 minutes. Probably that again you spend some more time and it's a peaker. Then you spend 5 minutes and now the screen says that now it will take you 40 minutes to reach home. So what is happening in between? So this is the classic example that the Google is actually probably refreshing its inputs at the back end, and the system is actually predicting on based on it that how much time it will take for you to reach home. And again, as I said before, this is one of the application which you really want to be accurate wherever it is, and it runs on that much of frequency. So you can think about it, that how much data points they are collecting to make this accurate as much as possible. The second example I would like to talk about is when we talk about machine learning AI, people most of the time talk about Apple, Google, uh, and then now there's OpenAI as well. But there are a couple of Indian companies, those who are making significant progress, I would say, in the AI world in machine learning. And these are the small startups at times, and they're really doing good innovation in that area. So one of the company I would like to talk about is Sictuple. Sictuple is a small company trying to come up with affordable medical diagnosis solutions. So this particular machine just uses a microscope, a cell phone, and the cloud base, a cloud where they can get this data, crunch this, run their algorithm, and put the results back. Now, what exactly they are doing is, now if you compare it with the real world, that somebody come and collect the blood samples from you, and when they collect, they actually take it to a lab. They analyze that blood sample and then figure it out whether your hemoglobin probably stays in valid range or not. Now the entire process probably, it's very time consuming and involves cost. At the same time, what if a computer can take certain decisions based on the samples and can give you the results without a technician, or probably without a lab guy looking into it? So this is the place where actually you're saving manpower job as well. And this is very useful in the remote areas in India where you do not have proper medical services available and the diagnosis or probably testing labs available, and this machine can be taken there and it can generate the results for the sum of the test, which is phenomenal. And uh, again, as I said before, that when you're talking about machine learning and AI, uh, it's not possible that you don't talk about the trends going on with the apps which you use on day-to-day basis. One is Uber, and why I've selected this app is uh, the thing which I'm going to talk about is not visible to you guys, but this really works as a charm. So next time when you go for let's say you go for a movie or you go for a match, and it's if you are there in peak hours, as soon as you come out of the stadium or the movie theater, you realize that there are many cabs around you already. So how exactly they know that you want to actually hail a cab in next probably 30 or 20 minutes? So this is where Uber is improving its technology in such a way that it informs the driver in advance to reach to a destination which can give them good, probably which can give them rights. And even that search is also based on the surging charges. So they also highlight the areas where the surging charges are high. So the drivers, those who are in low surging charges, can move to the high surging charges. So you may be paying probably 1.2 or 1.4, but probably that suddenly they inform the drivers that there is an area where the high surging is going on. Why don't you move to this? This particular interface may not be available to you guys because that's a part of Uber's drivers app. But if you get an opportunity to look at it, I would say that's one of the good example to show that how in real time the data has been used to show that to drivers. Now, with all that, uh, we'll we've reached to a point where I would like to talk about certain techniques and algorithms in machine learning world. It's a very old term, but now it's very popular these days. And as we all know, there are sub segments in machine learning. One is the unsupervised learning, where we do not have information or probably the tags available about the data. One of the example can be that you have certain pictures, but you don't know who all are in those pictures. So it can be a picture of a dog, it can be a picture of dog, cat, or probably anyone else. So you probably don't have a tag available to talk about it, that what exactly that refers to. On the other side of the machine learning world, which is a supervised learning world. In supervised learning, your intention is to optimize it. And by optimizing it, you already have a cost function available. So to simplify this, you already have tags available. You already know that which data is coming from which particular segment, or probably you already know that who is buying what. Instead, in the unsupervised way, you have no idea that uh, probably about your customer or the object you want to classify Uh, there's one more subdivision of machine learning, which is reinforcement learning. This is very famous, and again, I would encourage uh, each one of you, those who may not be aware about reinforcement. Recently, the toughest game on this planet to be played by a computer, which is AlphaGo, uh, was won by a computer last month, and that's the significant process and probably one of the great achievement in AI world, that a computer can beat a, a best player in that game. Since the normal games are pretty easy to play for computer because they look at the moves and then they try to learn it, and every time you probably play a new move, the computer will learn it and remember it. But games like AlphaGo, where you have probably billion or zillion moves on board, it becomes difficult for computer to actually create a tree for it. So that's one of the area. Considering the time frame of this webinar, I may not be getting into that space, but we'll be doing one case study on the unsupervised learning, that will be clustering, and one case study on the supervised learning side, that will be doing regression in this webinar today. And as I mentioned before, that this all this will be doing on R. So this R code will be available for all of you guys if you want to try your hands on. Now, considering the today's world and uh, the amount of tools available to all these jobs, run all these algorithms, uh, get this data, probably munch this data, get it into the right format, or probably collect all this data. There are, I would say, there's many, probably there are numerous number of applications available to do this. Most of the time, these are the languages which you can use to do a certain kind of job, and not every world is perfect in terms of covering the every aspect of probably machine learning and data warehousing. So on, if you look at R, which is a great tool for statistical analysis, and considering its popularity now and the available package, it's actually outnumbering the other tools, because probably all the possible libraries and algorithms are available on R these days. I would say that all which you'll be using in your daily life is available. Uh, on the other hand, Python, which is uh, little old in research world, and I would say the developers also like it because of the kind of development environment it provides, and which is little different from R, because the R is for most of the time for analytics purpose, but now the people are running it on big data sets as well. So on the other hand, you can run Python, which has equivalent features. But I would say in some of the cases, you may find something available in R which may not be available in Python readily. So you may have to write from scratch. Yeah, it can be algorithm or functions as well. And one of the example for data analysis is Panda, and for machine learning algorithms, it's Skylern, which is again it's a Python offering. Uh, on the other side, to manage all these databases, because end of the day you'll be consuming data from the databases, you have Hadoop, which offers you probably SQL and non-SQL options to query this data, probably store it and then render it. These days you also have real-time data sets available. So if any one of you is interested to do any sort of time series analysis or anything which involves real-time data, can be done with the open source environments. So right now here we are talking only about the open source environments without paying a single penny to anyone. In this case, Java is a big fan of Hadoop. So if you are good in Java, probably the operations which you do on Hadoop side on in Apache world probably will become easy, because the entire system has been written in Java. Whereas the Scala gives you the kind of functionalities to do machine learning jobs. which can directly be done on the clusters itself, directly on the big data sets, rather than taking this data or writing scripts in R or Python. And the third thing, which is, as I mentioned before, the computer vision, which is a very active field right now. I'm sure you all have heard about autonomous driving, which will be possible. Probably you have probably have running model or probably fully autonomous car running in US by end of this year. So, and computer vision has really grown a lot in last 3-4 years, considering the neural networks and deep neural networks that provide you the opportunity to probably give you a lot of AI stuff in computer vision side. Uh, and that's what actually the GPUs and NVIDIA's Intel are probably working hard to uh, probably come up with the chips that can where you can embed the AI directly or the machine learning somehow. All right. So the next segment today I'll be talking about is algorithm and techniques. Again, this is, I think, this is a very popular area. Uh, if you are doing data science and then everyone talks in jargons, and if someone's talking about let's say in clustering world, that probably, okay, which clustering you're running, how many nodes you have, and how many centroids you have, uh, why is the reason, probably into asking you that why is the reason that you have selected only 3 or 4 clusters, uh, why you have selected the regression over any other method, those kind of things. So algorithms is, again, it's a quite interesting area of data science. I would say that after doing the data part or doing all the data jobs, that's the most interesting thing anyone would like to do. uh, but it takes its own time to learn it use cases and then figure it out when to use where and why you're using, and what is the, again, as I mentioned before, what the business value you're generating. So in our normal world, there are 3 ways through that people are actually consuming algorithms, or these are main areas, I would say, are related to data science. 2 of them come from statistical world, and now the third one, the modern algorithms, which really work on big data. Uh, I would say that this is a zillion or billions of lines of data, which you take it as a bunch and then run it as a black box machine. And uh, is one of the example is the deep learning or deep neural networks, where you really have no idea that what is happening at the back, because there are so many neurals available in the probably the in the processing, that there are so many neurals involved that probably you don't know what is happening where. Where in the classical world, in the on this statistical side, the statistics part, like, again, that branch is divided into uh, 2 mainstreams. One is the classical statistics, where you have all the classical statistic tests which you do on data sets, and then the second one, which evolved later, is the Bayesian method of doing it. Again, as I said, that these are little advanced topics. If you get into it, probably if you spend some time, uh, you can explore it further. But as I said before, this is not in the scope of this webinar, but I really wanted to mention it, so that if whenever you get time to read about it, probably you can gain some knowledge about them. uh, as I said before, that the world is moving towards crunching the numbers in the black box fashion, so where you have algorithms, and most of the time those algorithms from mathematics will coming from the linear algebra. So this is the one of the major region, probably, I think, one of the subject, I would say, that if you want to master, to understand these algorithms, you need to understand the math behind it, to talk about it completely, that what is happening and why. But uh, there's one more point, that in some cases you really need not to know what is happening in the back, if you know the basics only, and you really need not to know math. behind it. You can talk about it in normal layman term and can actually communicate to business without getting into the math. So it's completely up to you that how much you would like to explore, how much you want to know about it, and how you want to use it. All right. With this, I move to the very important segment, which is feature engineering. As I said before, your model is as good as the features you are putting into injecting into it. Sorry. And as soon as you take the data, so your original data set can be as large as probably a couple of thousand of columns available, uh, and you really don't want to use all of them, because most of the time, probably if you have that size of data, then you may not have relevant information in columns. You may have a lot of missing information or probably garbage where you're asking about an email address, and then customers are putting just random things into it. So that completely doesn't make sense, and then you probably want to get rid of that. You really want to just take the variables which really make sense and give you the higher accuracy. So in data science world, as we say that how much variance you can provide in terms of data sets, so how much I can know about the customer is in layman terms. That if you can give me the variance, okay, give me the like probably the variance as much as possible in data set, and the algorithms probably try to shrink that variance. uh, Again, I'll talk about it in the later slides, but the goal here is to look only for the features, uh, those who really make sense for you. And there'll be certain techniques which you can use where you have, let's say you have tremendous amount of data, but you have no idea about the business, or you really don't know that which particular variable will make sense for me, where you are in a room, or probably that's your first day in your job, and you really don't know much about the business. So how do you use it and probably go ahead with it? So there are certain algorithms that helps you to do that, but the disadvantage of all those algorithms is that they transform the data. So they, as soon as they transform the data, you you may not have the actual information, so you have a transformed version of the data which you can't interpret to business, because the numbers have changed, because it has probably changed, excess probably it has rotated in the space. And so end of the day, you really compromise either on the business side or probably predicting right. So as I've mentioned before, that your business value, end of the day, the domain knowledge you have matters a lot. And this is where probably good analyst or good data science guy look for proper business knowledge before working on a project. Try to understand it, try to understand the business, try to understand the data. And believe me, in any project, the more you know about the data, the less headache it will be for you to probably later just come back and improve it. So there'll be high chances that you look at the data if you know it so well, and you can just say that this only makes sense to me. Rest everything is probably not relevant at all. Though it's your job to figure it out over a period of time that what else can be used. But initially, when you're starting a project, you can just your business knowledge plays a major role here. Now, a little now there are two techniques I want to talk about. If anyone who has their microphone on, can you please put it on mute? All right, thank you. So there are two areas I want to talk about. As I as I said before, that let's say this is your first day in your company, and somebody has given you a data set which you probably have no idea about it. So you don't know that what and which variable, and end of the day, what to use for your modeling. You want to go back, try to understand it, but the process may take a couple of time, or probably a couple of days. uh, Probably you have to spend 3 months before understanding each and everything, but the business can't wait for it. So then in that case, what to do? So you have two options: either you probably spend more time on data and try to understand it, or you, on the other hand, use the algorithm that can transform the data and can give you a data set which has the high variance but the less variables which you probably have. So it probably take out all the redundant variables which doesn't make sense for modeling purpose, and it only gives you the data set which is highly probably which can give you the higher accuracy end of the day, and which gives you the most of the variance available in the data set. And by variance I mean that the information that the how much I can know about my customer, that so the variables, so probably the some variables can be correlated with some other variable which really doesn't make sense for me. So you're maybe that uh, let's say your family size can be correlated with the total number of, or probably the total income of the family, and it can be highly correlated, which really doesn't make sense. So you only take one variable out of it because the other one is just correlated variable. So in that space, it helps you to reduce or probably shrink the data size and can give you the variables which can perform well for your modeling purpose. Now, there are two ways, or probably there are multiple algorithms, and I have mentioned two on this slide. Is one on the left hand side, which is principal component analysis, which is quite old and very famous algorithm. Try to look for a linear space. So they look for the variables which is correlated to each other, which really don't give you much variance in your data, and then just throw the variables which is not required, and which doesn't give you the variance which is already been provided by the earlier variables. On the other hand, since that this has been used in industry for a very long time, there are certain new algorithms people have come up with which can also figure it out, their polynomial relationships. So maybe that the one variable may be related or probably correlated to the other variable, but they can have complex relationships as well. So probably you have polynomial relationship where that probably you take one variable and the certain variable is not directly correlated, but there is polynomial relationship. So people have come with the algorithms which can look for the complex relationships in the variables as well. Now, how it helps is that the biggest disadvantage of using any feature reduction algorithm is that because it actually threw away a good amount of data for the variable. So you have no idea that whatever you are throwing away, how useful that can be probably right now or later in the stage, where the new algorithms look for the complex relationships as well. So maybe that the PCA which figures out, let's say, 8 variable out of 100, TSNE kind of algorithms can figure it out, let's say 13 or 14 variables, because they can look for some other variables also in that space. There are also chances that it may further shrink also. So let's say that your since PCA is looking for 10 variables because they have linear relationship, where TSNE is looking for certain variables which have complex or probably polynomial relationship. So it may even further reduce this as well. As I said before, it has its own disadvantage of throwing away the information, and if you have no choice, then probably these are the safer ways for the feature reduction. There are other ways as well uh, to use the variables, and that can be that the uh, backward uh, uh, probably a backward deduction. So you are just running algorithms and looking the variables and just taking out the variables just to check that whether it impacts the accuracy or not. But again, as I said before, that there are many algorithms, and that's probably something that we really need another uh, probably seminar, probably the more time to understand it. All right. Uh, with this, we come to our first uh, case study. Uh, as I said before, we'll be covering one regression case study and second, like one clustering case study. The first one is the regression, where the first example is that we are trying to uh, come up with the revenue. We're trying to predict the revenue, the item revenue, uh, by after looking at the other variables, and the other variables in this data set which you can look at is the number of instance a person is actually number of times he's adding something to his card, number of unique instances, total number of probably how many times he's adding things to his card, probably has removed something from his card, and the amount is also, and the number of page views. This is something which is from the online world, so it has page views and the total number of unique products they have seen, and the amount also which they have spent. uh, Now to work on this, as I said before, it's a regression case study, and what we are trying to predict here is a regression line that can fit our data set and can give us uh, the a slope and a line which help us to predict the total amount the amount the revenue for the item in this data set. And for this moving it I'll be moving it to R. Just give me a second so I can change the screen. All right, great. So the first thing what we're trying to do is that we'll load this data into R. Uh, I've just set my working directory so I can directly read the CSV file and can see the columns. On the right, you can see that it has 10 variables and total 92 observations. So it is like 92 lines with 10 variables. Just to look at this data, just to check that what we have in this data set after uploading it to R, we can do a summary analysis on our data set. It will give you the quadrants, first quadrants, median, mean, and the third quadrant. The summary really helps you to identify how your data is actually probably have put it up, have some sort of outliers into it or not, or how the distribution looks like for your data set. So if the distribution looks pretty good or probably decent, then what you can do is you can rely on the standard approach of just creating model on top of it, and then start predicting on the new data set. But most of the time, what you need to look at is that the distribution will be you will definitely find some of the data points here and there where you will include them as a probably in the category of outliers, or they don't fit in your data set. You also need to look at for the null values, because that most of the time in your data set people generally find null values. So those are the common checks which you need to do probably all the time, just to make sure that your data is right before putting it in the model. As I said, it has 92 rows, and then what we do is, since this data set uh, has a certain the column names uh, probably a little big, so what we do is we just convert it into a small version of it, and then we can run the model. Now the important part, this data set, since it's a ready-made data set and it's available in a cleaner format uh, in public libraries, so we really don't get to see something fishy here. But most of the time when you're working with real data sets, that you will get challenges to actually bring it in a structure, or probably uh, in a way that which you can use in your for your modeling purpose. And for the model for that there will be a couple of steps which we'll be doing in a second exercise, just to show you that how you can actually remove the null values, or just completely get rid of them, and then make a model on top of it. For linear regression, we already have an inbuilt package in R, so you need not to install anything. It comes along with standard R package. And what in this formula, what it is doing is that it is taking your revenue. It's trying to create a regression line, try to predict, create a model to learn the revenue, and then all the other uh, independent variables which we are feeding into in the regression model. So this is a uh, this in this particular scenario, you'll be seeing that since we have included a couple of variables here, so the total accuracy of the model will go down. And this is a general behavior of any model where you have a lot of variables available, and the accuracy will be comparatively low if you compare it with less number of variables. As I mentioned before, because the entire space become complicated, and whatever you are including, that how relevant it is, and how much variance it provides it to predict your dependent variable. And here your dependent variable is the item revenue which you are trying to generate. So after doing this, you just look at your summary for the model, that whatever you have just trained. And this is a very important step in in your modeling process, to analyze whatever you have trained, that how good that fit is, and if you find something. So this is this step where you have to go back and forth to your data set, change something, and come back and probably train the model once again, look at the statistics of the model parameters, and then just to make sure that the accuracy is right, and probably everything which you're feeding in the model is in right format. So most of the time it's the data issue that creates problem to uh, to train the model or probably learn it better. So what's the first thing which we'll actually look at is your residual. So it, in the normal world, it's supposed to be distributed. So what residuals here is that the actual value uh, and the value with the intersect line, probably the slope which is actually trying to fit the data, and the gap between it. So if you're taking a data set and the sum of square, probably the total the error which you have, if you look at the distribution of it, so you'll be have some values above the line, some values below the line, and if it's normally distributed, they will cancel each other out, and you have less error available, less error in your modeling. So in this case, the accuracy which you're trying to predict, and look at the quality of the model, is that where your median is sitting. So if your median is close to zero, then you are in good space. Yeah, it has done its job pretty well. But if it is not, then in that case, you need to go back your data and probably do further steps to try to reduce this. And these steps can be removing the variables, at times normalizing the variables, because their values will be completely different. So you may have to put it in the same range. Uh, there are a couple of things here. Again, as I said before, these things matter a lot when you are uh, trying to uh, probably take this data, this model to business, and probably presenting this to tell them that what exactly is important to predict the revenue in this case, and which particular variable is important, why it is important, and how it is performing. You'll be doing it in your layman language, but there in this screen, probably you need to understand that which number is falling in which category and what can be done. Uh, I'll not be going very much into depth here, considering the time limit we have. But the important things I'll be covering is the intercept, which is the minimum value it starts with. Uh, so in this case, that it is in minus, so probably the slope which is actually going, which is crossing on your x and y at the zero, probably it actually goes from minus. So probably the fit which you're actually seeing here is actually below the uh, zero. And important variable. Now, two important things. One is the standard error, which the particular variable is creating the model, and the variable's standard error is supposed to be as low as possible. So if you look at the variables performance, like if you can look at the variable cart at total rupees, the total value a person has uh, probably generated through the cart, uh, adding things to cart applies, probably gives the most variance in the model, and uh, has pretty much provides more information about the item revenue which they're gonna buy. And so in this case, you can see that it's 1.3, but you have these -0.2, so it's probably in decimals. So it's pretty low. Everywhere else, it's not that significant enough. There's one more point here, but again, the value is comparatively high. And one thing which you'll be checking is since they have added this feature in their inbuilt package, that it already gives you the probability significance here, that how important this particular variable is. So in this case, if you have, the more the stars, the, the better it is. And in this case, uh, where you have 3 star, which is the maximum, so it has the high probability of providing information about the dependent variable in your model in simple terms. uh, all the all the models, and even in the competitions as well, if you are doing any sort of analysis or have taken any project on Kaggle or any other site, and if it's a regression problem, they give you the success metric as r square error. So r square is that how much variance probably your variables are providing for your dependent variable. So if your r square is like here 0.7, so means 70%, and the maximum value it will take is 1, so that will be 100%. So the 100% means that the variables actually completely, like, they provide also all the variance for the dependent variable. And in real time, in probably in real world, that's not a good way, and that's not a good number also, because let's say that if you already have 100% variance provided by the trained variables, then what will happen is when you train this model on your training data set, on your testing data set, I'm sorry. So the r square will automatically go down because you're overfitting your model. You're trying to fit it completely, and then with the new data set, that may not be the case, because that the data which you're training right now, you're trying to learn everything from it, and then what will happen is that it will only learn about these variables and this data set so much that the new variable and the new data set will not perform well with these estimates. All right. I'll be actually going through a little faster uh, because uh, we're considering the time and we have to actually cover 2 more case studies. Uh, the second case study is on clustering. So in clustering world, what we do is I wanted to actually present the PPT, but I need to stop this so I can. What I can do is I can cover here. So in clustering world, you have 2 ways of representing your clusters. One can be uh, a normal standard to the production, and the second can be a hierarchical clustering. And just to give you a jinx of it, just let me present it. All right. All right. So in clustering world, either you really want to cluster them in a 2D world on your left hand side, as you can see. And for this sort of clustering, what you need to do is you need to figure it out, the centroids. You need to figure it out at how many clusters you want to make. And one example can be that you want to categorize your customers based on, let's say, their t-shirt size. That's who all are according to probably other measures that fall under small, medium, or large. And in that case, you have 3 clusters which you're making. And on the right hand side, you can see hierarchical clustering. Hierarchical clustering is again one way of representing the same clusters But what you can do is you can actually select that to which level you would like to go. So on your right, let's say you have a data set of PQRST, and on the second level it will make two clusters which will be PQ and RST, and it's again hierarchical, so you can stop right here. But if you, let's say you want to further classify, so you further classify RST, which is a big cluster, and that will make two clusters out of it. That's like R, and the second one is ST. So this is how you can decide that which level you would like to make a cluster at, and then probably accordingly set the approach to it. And this completely depends on the business problem you're trying to solve, and it really needs a business knowledge. And again, as I said before, that the data which you are using and then what you're trying to achieve plays a major role here. So in the case of t-shirt size, you already know that you want to categorize your customers in three categories. But let's say for a retail chain, they probably would like to categorize the customer probably in 10 categories. So the business and the problem statements can be different. Now with that, let me move to R. All right. So again, this is also one of the public data sets available. And in this case study, what we're going to do is that there is a European uh, data set for the protein consumption for different countries. So here we have actually taken 25 European countries and their protein intake based on their major food sources. So like what exactly they are eating, and then accordingly categorize them or put it into the clusters. This data set is available. It's actually it's a educational data set. You can download it from this link, and I'll just upload the CSV format so you can see how it looks like. All right. So here you can see that the it's the snapshot of the initial lines, and what it all talks about is the country. Uh, and in the columns you can see the different items which they eat, and accordingly they have taken that the protein intake in percentage in terms of in their probably daily diet, that how much it is like how much protein they're consuming through different foods type. And what we're gonna do is we want to categorize them in three categories. Again, this is based on their food intake, but you can take the same case or probably same scenario and apply it in your business where you are creating three clusters. And using this data set gives us the advantage to use a cleaner data set, so we not to spend time on data munging and cleaning it. So it's a clean data set, so it helps us to create the model quickly for the demonstration purpose. But you can take the same code, you can probably look for the data set, just take out the things which is not required, and the same case create the clusters in the same fashion. So I just set the seed so that the clusters which we get. Now, this is the difference, that if you are doing the k-means clustering, where you are initiating the clusters, you may get different results if you are not setting the seed. So whenever you initialize it, when you are training it, a country which falls into, let's say, cluster 2 might fall in cluster 1, and when the second time when you're running this. And why it happens? Because every time when you run this, it initiates the clusters, and then it starts with the different, and every time it starts with the different data points. And so accordingly look for a centroid in those data points, and it may move. So a recorded probably a country that falls into one cluster, in next time initialization it may fall into some other cluster as well, if it is not very much close to the centroid for the first cluster. So that happens. So just to make sure that we get the same results, you set the seeds so that so it can retain the values, and every time whenever you are initiating it, can initiate from the same point. uh, I just train the model for the key means, and what it's saying is that we are not taking all the variables for for this analysis. We're just taking two food items. One is the white meat, second is the red meat. We are creating three centroids, means three uh, clusters. And as I said before, that it starts with a random initialization, so you actually give the initialization value as well. And after doing this, after training it, uh, I'll just show you the statistics generated out of it. So you can see that it has created three clusters, and the cluster size for them is 8, 12, and 5. So out of all these 25 uh, countries, what it has done, it has created three clusters, and it has, according to them, and what the cluster means, which you can see, these are actually on the axis. So what you're doing is you're putting it on a 2D. If you can imagine it, it's on a 2D, and if you can just imagine the where the centroids would be located, then you can see it by these points. And then what exactly should be looking at for the clustering is that what exactly is the sum of square by cluster. So now the sum of square value is the clustering method works in this way, that you have your sum square. So within cluster, what is the error rate and how my clusters are distance apart. If I take the distance between the centroid, so if the better they are enclosed in the cluster, the closer they are within the cluster, and the distance between the centroid is maximum, means this is the best clusters which you can get. And those are two parameters which you look at. So one thing is the within sum of square by clusters, and you can see the second cluster have sum of square higher sum of square rate. And again, as I said before, that it's been initiated. Again, it's a randomly initiated. So next time when you run it, you may get some fluctuation here and there. But this gives us some point that we can do some sort of data tricks to reduce the sum square within the clusters also somehow. And one of the trick that works most of the time is that the data distribution. And if you look at the data, and if you know the variables pretty well, and if you see that for the sum of the variables, the data range, let's say, is between 0 to 100. For the other variables, the ranges are, let's say, between 200 or 250. So it means there is a range gap, and that's a reason that can create some trouble for you in terms of calculating the sum square within clusters. Um, but at the end of the day, this is not the list which you provide to business. So the business, what need is that you give them a list where you can tell them, okay, these are the countries, and this is the cluster in front of them, cluster number they belong to. And that's what we do in the other process, in the other step. So what I have done is, you just take the cluster numbers which is being generated, which you have trained from k-means, and then you create a data frame out of it, which I just did, and in which you have your country, and respect to that you have the cluster numbers they are assigned to. You can see Australia, Denmark, Hungary, Poland, they're all in cluster 1. uh, there's a cluster 2 which is actually a cluster. If you remember that the second cluster is actually 12 uh, data points into it, and the last one have 5. So these are the 5 countries. But again, for the analysis purpose, you would like to see it on a plot to exactly evaluate that how the clusters look like on plot. And that's what helps you to identify that whether the clustering worked properly or not. So what you can do is you can plot this, and this is how it looks like, RGB. uh, and so in the RGB format, like it's 1, second, and third. So you can see that the pollen, which is in the first one, there's a second one, and this is the third one. We have 5 countries, and this is how this is the representation looks like. Again, as I said, that you may would like to see it in different fashion in probably in some other way, but this is for the illustration purpose, so you can visualize it in better ways as well. Now, the the second case study which I would like to show here is the social networking cluster analysis. This data set is also a very known data set. It's a data set of students in US searching for actually for their social network uh, sessions, and then the words which they have used in those sessions, and based on all those words which they have used, uh, whatever the content they have written on those on the social media, we take the major words, we look for the words which occur most of the time, we take it and then categorize them to create some sort of personality trait out of it, so we can say that what exactly, what which particular cluster they belong to, and we can further break it down to do any sort of further analysis on top of it. So I just upload data. So just since it's a big data set, as I mentioned, because this is 30,000, so we'll not be looking at, we'll not be generating summary out of it. There's no sense. So what we do is we just look at the first 3 lines, and that gives some idea that what all variables it has, and what is useful for us. So you can see their graduation year, gender, their age, how many friends they have on social network site, and the words they have used on social networking. So let's say that this guy have used football. So every time when he has like if he has used football, you can see 1, else it's 0. So if they have used let's say word cute, so this female has used word cute, so it's been marked as 0 and 1 in binary form here. Uh, Now it's a big data set, so some of the things which you need to check is this is the example where you need to do some sort of data merging to figure it out the data is right. And this is the intention of including this data set, because this is the area where you get some real-time data analysis feel that what can be done. You can see there are 30,000 rows and 40 variables, 36 words being selected, and rest of 4 variables are the graduation year, gender, age, and friends. We we may not require these variables because this doesn't make sense, and to make any sort of clustering out of it, either you can create variables or just take the words which they have used and make a cluster out of it. Uh, so it's already known, but what you can do is that you need to look for the null values. So pretty, since it's known data set, so if you look at the age column, you can see if you generate the statistics out of it, you can see there are 5086 null values into it. And so to create any sort of model, before creating any model on top of it, what you need to do is you need to get rid of these null values, so you don't have probably, so the clusters can perform well. And what we do is that we are taking out all the rows where we have null values. This is a very strict measure. So probably you really don't want to remove rows where you have probably the one of the column probably is null value. But in the data set, the data is not it's data doesn't have that much of issues, so you can remove the null values. But in real time scenarios, you look for the columns which have the highest null values, and if in standard way, let's say if a column has more than uh, like if the column has around like 60% or probably 50% data, uh, then you probably may not be able to use it. But if you have like around 70% of data available, then it's a good practice to come up with some sort of imputation technique to generate rest of the data. And these techniques can be that you look at the maximum occurrences, like the categorical variables, like let's say whether they are male or female. What you can do is uh, well, again, that you need to either, if you have a variable available which is Mr. or Miss, probably you can generate with mix and match. Or if it is not available, then what you can do is you can look for maximum iteration. So if in your data 60% of them out of 70%, 60% of them, let's say, are male, so for the rest of them also you can take the same ratio to generate it randomly. Again, this is a task of feature engineering, and it all depends that what is available and how you can come up with the logic uh, which can work on the data set with to create these variables. Now I have just taken out uh, all the values where we have null, and now you can look at the data size, the data frame size, which is around 24,000 rows and 40 variables. As I mentioned before, to create clusters, we don't need the initial 4 variables, which is graduation year, gender, age, and friends, that doesn't make sense for clustering purpose. So what you can do is we can generally remove it and we take this subset out of it. Now the new data set, which you can see here, is have 24,005 rows and 36 variables only. Now, one of the exercises which I didn't perform in the previous case study is to standardize this. And why this is required is because, let's say a person is using word music, let's say 5 times, whereas a person is using same word 1 time. Uh, it's because this is not a direct comparison, because the other person is using some other word less, and then this is not on the same scale. So what you need to do is probably you actually scale the data now so that everyone falls in the same scale. So you can cluster it, and this exercise really helps you to if you can normalize and scale the data on a single scale. So it'll be so, and this exercise helps you to handle the outliers. Like you may have one student which uses, let's say, a word volleyball, let's say 50 times. But it's again a outlier, so it's not on scale. So probably the person may not fall in any of the clusters. So you need to scale it. And once you scale it, that probably all the variables are on the same scale. And then uh, we are creating 5 clusters out of it. Uh, I will also uh, I will also talk about that how to choose the number of clusters after this case study, and how you can figure it out what is the optimal number of clusters which you should be using, because in most of the time you may not have a clear business idea that how many clusters you can create. So you can do is you can take help of certain analysis that can help you to figure it out, that what can be the optimal cluster size. All right, so we have created 5 clusters out of it. And again, as I said, that as soon as you uh, run any model, probably you would like to analyze the results. This way, again, there's one way of looking at it. When looking at it, these are the intercepts. If you put it in a 2D dimension, which and in this case really doesn't make sense. So the best can be is that you can put this into a pie chart. So you can create probably the 4 charts and that can talk about these clusters, and that's what actually I've done here. Now these charts are a little small. I try to stretch it as much as possible. I don't know how much you can see it, uh, but there's no further zoom available, so we need to live with this. But you can see in the first cluster you have like people those who use word dress a lot, but in the second cluster you have people those who use word hair a lot. In the third cluster you have people using word music a lot, and in the fourth one you have like the fourth cluster, which is again which is low on variance, because the first 3 clusters have covered most of the variance. So this one will be a little mix, and this has music here, and you can see also word drunk. Uh, so yeah, so these are the four clusters which you have, which you can see for your illustration purpose. Now the most important part, that how to select the number of clusters, because most of the time we don't know what can be the optimal number of clusters we should be selecting, and is there can be a way through which we, like a model can select the clusters on its own. There are definitely ways, but uh, there are two ways to approach this. Like one, you look at this, the result of uh, this technique, and then you can also verify it with your business that whether that makes sense or not. Because let's say that your business want to classify your customers, since you have a broad category and want to classify your customer in 7 or 8 clusters, where the technique which you're going to use tells you that you should be making around like only 4, so that what's supposed to be the a middle ground where you can where you have to create, or probably business has to probably reduce the total number of clusters, or you have to increase by after looking at the elbow chart. So for this, we'll be using one data set which is available with package rattle. Uh, yeah, this is this particular data set is little it's very interesting data set. It is a type of wine, and all the ingredients it has in that wine. Uh, so I've just taken the first 6 rows, and you can see that the type 1 wine has the alcohol level at 14.23, and it has malic ash and other ingredients as well. So what we're going to do is that with this data set, we're going to figure it out that what's supposed to be our optimal cluster size for our clustering exercise. And for that, what we do is we just take the type, because type is not required for our analysis. We need numeric numbers. And with this function, which does what it takes, it's a formula. So it takes the sum, and I'll be talking about this in some time. So what it is doing, it's trying to calculate the sum of square errors. If you remember, I was talking about it a few minutes before, within the cluster. So what it's doing, it's in this loop function, it is trying to sum uh, the sum of square errors uh, uh, after, like, by changing the centroids and looking at it at what after every new centroid, or probably a new cluster which you add, how the sum of square error changes. And I'll show you how it looks like. All right. All right. So you can see the sum of square, if you only take one cluster, it is the highest. If you add the second cluster, it reduces, because you have 2 clusters. Your data can be divided into clusters. So they can be pretty close. If you put 3 clusters, then again you can segregate further, like 4 and 5. But this is where you have to observe that the sum of square error is not reducing at that speed. So after 5 and 6, you can see that the slope is not that steep. If this is not, if this doesn't make sense, I'll try to show you this one. All right, so let's reduce this to 10. You can see that after 4, 5, and 6, that again the slope is not probably the steepness actually reduces a lot. So for in this case, the most of the variance being covered till cluster number 4. And if you want to add further clusters, it won't help much. Probably won't give you that much of classification within the clusters. But you can see that after 6, probably that it really goes down. So it pretty much doesn't help you after that. So in this case, I think 4 can be an optimal number. But again, as I said, this is as per your business requirement, and then which you can cross check, and then with your own data set, and then see that how that goes with your data set, and uh, what can be the optimal number which can be uh, which can be acceptable between the business and your model. All right. Uh, with this, that's our last case study. Considering the time limit, this is what uh, we can do today. And after that, I would like to open the session for Q&A. So I probably would like to welcome questions if you have on the content which you presented today. Guys, anyone any question? You can. Okay, thank you, Constant. Anyone else? You guys have any question? Any doubt, or you would like to understand something? Probably, or something which is related to your business, uh, which you want to apply. The first question actually I got it is like whether we can use MATLAB tool for this. Yes, so MATLAB is again it's a paid tool, and it has certain toolkits which you need to buy separately. So if you have MATLABs available with the right kind of tool sets, you can definitely perform the algorithms available with that tool. But as I said before, the it is not a free tool. So if it is available, then it's well and that's great. But if not, then most of the algorithms are available in R and Python as well. The second question is that where we can get to know the algorithms required for data science. Um, I would say uh, there are certain good websites like if you go to Kaggle gives you really good blogs about the new algorithms and probably the old or classic algorithms and the implementation in blogs. There are a couple of uh, books also which you can go through. But I would suggest that if you follow the blogs, and Kaggle is one of the best source to know about the data science, uh, probably the whatever is new in the data science. And there's one more website called Data Science Central, uh, but I would say that the Kaggle has kind of I would say Kaggle provides more information on the new technologies, and at times the blogs also includes the code which you can run on your own and see. All right. With this, I think we are done with the Q&A. And if any one of you have any question, you can also write an email and probably. All right. I got another one before we close. Uh, All right. So Ankit, in case of implementing data science methodology in every business scenario, it depends what you're trying to achieve. And if the business requirement, let's say, is it somehow meets the framework requirement. So let's say that we take an example that you probably your business doesn't need to learn something or probably implement something which generates scores or which generates some sort of output in probably at that frequency. So if your business needs any sort of prediction modeling, predictive modeling, or needs some sort of optimization, uh, then I would say I would highly recommend to look at the different areas. And in my understanding, in normal business scenarios, I've seen that there are a lot of opportunities available in normal business scenarios where you can implement probably one or two algorithms and can come up with something which can save total number of hours or probably can impact the revenue also. All right. Uh, I think that's all. Well, guys, thank you so much for joining. If you have any question, and so you can actually send an email on info@techcanvass.co.in. Again,
Thank,
thank you for
thank
joining,
you so
and
much, Vinayak sir, for your
yeah,
precious time. Hello everyone, this is Nazneen here from Techcanvass. And any queries apart from this, you can contact us on the contact number, our email ID. You can also go to our website. You can check out more details. Do get back us. And thank you for being such a lovely audience. Thank you everyone. Thank you Vinayak sir.
thank you, thank you, guys, thank you.
Thank you sir.